Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve literal equations when you're given a formula. And basically, again, when solving literal equations, again, the main important thing we want to do is understand the variable that we're trying to solve for. And a lot of times what I like to use, especially when you have literal equations forms, you have multiple variables, right? And that's a lot of times what makes it so confusing is, we can't combine things like we did with numbers. We have all these variables going on. So a lot of times what I like to do is pin the variable, basically circle it, and then use inverse operations to isolate or get the variable by itself. So let's actually look at this equation first here. So if you look at this, we'll have area equals length times width times height. It really doesn't even matter if it's a formula that you know or you don't know. All we know is we want to solve for L. So what I'm going to do, my first step here, is to circle my variable. Now, the reason why I like to circle the variable is it just reminds me to focus on that variable, to undo everything that's happening to that variable, to isolate it, to get it by itself. So you can see my variable right now is being multiplied by w, and it's being multiplied by h. Now, you could do the inverse operations for each of those separately, or you can do them together. Since we're multiplying both by w and by h, to undo multiplying by both those numbers, I'm going to need to divide by both those numbers. So I'll divide by wh on both sides using my division property of equality. Well, that now goes to 1. So I'm just left with a divided by wh equals L. So now you can see by undoing multiplication by using division, my variable has now been isolated. So now L equals a divided by wh. Now again, when we're dealing with variables, we can't divide variables into other variables when they're not like terms. So therefore, I'm just going to rewrite this with the L to the left. So L equals area divided by w times h. All right, so now let's go into this one, because this one a lot of times gets students stuck because we have a fraction. Well, and it's very similar to the other one. If you look at it, I'm solving for my b. So again, I'm going to circle my b to isolate it. And you can see my b is being multiplied by h. It's also being multiplied by a fraction. So once people see a fraction, they like freeze up and say, oops, I don't know how to do this one. So unlike this one where we did the same operations at the same time, let's do this one at different times. Now, the other thing that sometimes gets confusing is I'm multiplying in front of it and I'm multiplying behind it. Well, guess what? That really doesn't matter at all. And to prove my point, multiplication, 3 times 4 is the same as 4 times 3. So let's just rewrite this. So they're both multiplied to the right. And I'm going to keep my variable circled. Now, again, as I mentioned, we're going to do this one step at a time. So to undo multiplying by h, I'm going to divide by h. So I'll divide by h on both sides. Therefore, I'm left with a over h equals b times 1/2. And I'm going to keep that circled. Again, that pinning is telling me I'm not going to move the variable. It's going to stay right there. And I'm just going to undo everything that's happening to it. Now, how do you undo multiplying by 1/2? Well, you could divide by 1/2. Or the best thing I always like to think about when we're dealing with fractions, to get rid of your fractions, we can multiply by its reciprocal. That's not going to get rid of it, but that's going to multiply it by 1. And 1 times b will just be b. So what I'll do is I'll multiply by 2 over 1 on both sides. By doing that, any number multiplied by a reciprocal goes to 1. 1 times b is just b. Then I'm going to rewrite my answer like this. So I'm just going to write the b in front on the left is equal to 2 times a is 2a over h. OK? Now let's go ahead and look over at this one here. Again, this one looks pretty confusing because now we have a pi and we have an r squared. But guess what? It's the exact same thing. Again, it doesn't. The numbers don't have to be multiplied to the right-hand side. They could be also multiplied by the right on the left. However, I know this gets a little bit confusing. So again, let's just do it one at a time. So you can see h is what I'm solving for. So therefore, I'm just going to undo everything that's happening to it. Well, h is now being multiplied by r squared. So I'm going to divide by r squared. Therefore, I'm left with v over r squared equals pi over 3 times h. Now, my h is being multiplied by pi over 3. Now, remember, the reciprocal is just flipping the numerator and the denominator. So to multiply by reciprocal, I'm just going to multiply by 3 over pi. That now, again, multiplies to 1. And I'm left with h. Again, I'm just going to flip the equation. So my variable that I'm solving for is on the left-hand side. H equals 3v divided by pi r squared. Done. All right. Now let's go ahead and look at this one here. This one, again, we have more pi's. And it's like, oh my god, it's just like, it looks confusing just even looking at it. So I really think when you can look at isolating it, it's super helpful. Actually, this one probably would have been next, but whatever. So we go to h. Actually, let's go back and look at this one because that's going to stem off this one. So when we look at this one, now we're going to solve for w. So now we circle it. Well, now just instead of multiplication like we've done so far, now we actually have an addition too. So remember, using your inverse operations for solving two-step equations, we got to use the reverse order of operations. So we have to undo addition and subtraction first. So to undo adding 2l, we need to subtract a 2l. Therefore, I'm left with p minus 2l equals 2w. Now again, you cannot subtract 2l from p, so we just leave it like that. Then the next thing we need to do is now undo multiplication by 2, because right, we need to get the w by itself. I circled it, I want it by itself, isolated. So to undo multiplying by 2, I need to divide by 2. Now remember, this 2 divides into the p, as well as 2 divides into the negative 2l. Well, if I flip this around here, I write w equals, well, p does not divide, or 2 does not divide into p. So I'm just going to leave that as p divided by 2. Negative 2l can be divided by 2. I can divide the 2 into that coefficient. That's going to leave me with a negative l. So my final answer for w would be w equals p divided by 2 minus l. Just make sure you divide that 2 into both of those terms. OK, so now we can go to this one. So when I go ahead and isolate this, you can see actually this problem is almost exactly the same as that one. It just looks a lot more confusing. My h is being multiplied. But instead of just being multiplied by 2, now my variable that's circled is being multiplied by 2 pi r. That's OK. It's also being added by 2 pi r squared, which is a little bit different than being added by 2l. However, the operations that I'm going to do are exactly the same. So let's undo adding 2 pi r squared. So I subtract 2 pi r squared on both sides. So I get s minus 2 pi r squared equals 2 pi r h. And again, my h is circled. OK, you can't combine them, so you just leave them as subtracted. Now, we need to undo multiplying. Well, everything's being multiplied by here, so I can do it at the same time like I did over here. So to undo multiplying by 2 pi r, I'm going to divide by 2 pi r. OK? Those all divide to 1, leaving me just with h. So now I'm just going to flip the equation again, because I just like to read my variable that's isolated on the left-hand side. H equals now everything over here. S minus 2 pi r squared divided by 2 pi r. Now, I could have done, left this equation like that. W equals p minus 2l divided by 2. Instead of dividing those both into that one, that is the correct answer, but it's not really simplified. In the same form, this really isn't simplified. Yes, 2 pi r does not divide into s. However, 2 divides into 2. Pi divides into pi, and r divides into r squared. So I can actually simplify this as h equals s divided by 2 pi r minus, that goes to 1, that goes to 1. That leaves me with r. So that's actually going to be my final form. Just make sure when you're multiplying a binomial by a single term, you divide that term into both of those terms of your binomial, which I did here, which is how I simplified this. On the last example, this one gets pretty confusing because students see parentheses and they're like, oh, God, what do I do here? Well, I could have done this one before. Again, we're solving for h. So I look at my h and I see, all right, my h is being multiplied by 1/2, and it's being multiplied by b1 plus b2. Well, that's in parentheses. So I can undo that just as it is in its parentheses. Therefore, I'm left with a divided by b1 plus b2 in parentheses equals 1/2 h. Well, like I've done before, to undo multiplying by 1/2, I just multiply by the reciprocal. And my final answer is going to be h equals 2a over b1 plus b2. So there you go, ladies and gentlemen. That is how you solve literal equations when given a formula and inverse operations. Thanks.